Today we will learn infix to postfix conversion. So before starting with the problem, we need to know some terminologies related to the conversion. So the first one is operand, operator, infix expression and postfix expression. So let's understand each of these terms with an example. I am taking a simple example, a plus b. Here a and b can be variables or constant. So these are called operands. And the arithmetic operation performed here is addition, and this plus is the operator. So therefore these operators can be plus, minus, division, modulus or exponent. And operands are basically variables and constants. So next is infix expression and postfix expression. Depending upon the position of operator, we can determine if the expression is infix or postfix. So if the operator comes in between the operand, it is an infix expression. Whereas if the operator comes after the operands, then it is a postfix expression. If the operator comes first followed by the operands, then it is a prefix expression. So in general terms, you can write operand 1, operand 2, in between we have the operator. Here operand 1, operand 2, followed by operator. So this is a general representation of a infix, postfix and prefix expression. Now let's move into the infix to postfix conversion. So let's take this question. I have taken a question in such a way that all the rules can be applied in this single question. So with this single question, you should be able to solve any questions from this portion. To solve this problem, we have a set of rules. I have made a chart to make it look easier. This is the question. We are taking the help of stack data structure to solve this question. So we have to make 3 tabular columns. One is the input, second is the stack, and third is the output. So this output will be the final postfix expression. So this output will contain the final postfix expression. The input is nothing but the scanned symbols. So now that we have this expression in hand, so by looking into the expression, we can understand that this is an infix expression. Why? Because the operator comes in between operand. Everywhere it's the same. Operator comes in between operands. Operator comes in between operands. So we need to take each symbols one by one. First symbol is K. So first we will read K. So input is K. Now we have to check what type of symbol K is. What are the possible options we have? So we have these many options. It could be operand, that K, the red symbol could be operand, operator, or any of this, or end of input. So it is a operand. So for an operand, output the symbol. That is what the rule says. So we have to simply output this K. Okay, so stack is empty. Okay, empty. We don't have anything inside. So we will just output K. Now read the next symbol. The next symbol we have, it is plus. So read plus. Now again we need to check. So we have scanned it. We are going to check whether this plus is a operand, operator, or any of this. So it is an operator. There are 2 cases under operator. One is the stack is empty, stack is non-empty. So stack is empty. Therefore, we have to apply this rule. Push the symbol. Push the symbol. So plus we are pushing it into the stack. And output remains just K. We are just writing this one below. Next is L. So we are going to write L here. Next input is L. We have already seen what we have to do with an operand. We have to just output it. So we are not going to perform any operation in the stack side. We are just outputting the operand. So the operand will be KL and this remains the same plus. We'll see the next symbol. It is star. So star is an operand. So we are again moving to this case. It is an operand. But now the stack is not empty. We already have a plus sign. The stack is not empty. So we'll move into this condition, non-empty stack. So if the stack is not empty, then we have these many cases to be checked. So now the incoming symbol is star. So we have the incoming symbol as star and on the top of stack we have plus. So we have to check the precedence. Since there are two symbols involved, we have to check the precedence. The precedence comes in this order. Exponential has the highest precedence. Then comes division and multiplication. Then comes addition and subtraction. This is the topmost precedent and this is the least one. We'll see associativity as well. So associativity of exponential is right to left and all remaining others is left to right. We'll see how we can use this in this example. Now that we have star as the input and plus as the top of stack. So according to this table, we know that star lies here and plus lies here. So star is having more precedence than plus. This is according to the precedence level, okay? So the precedence levels comes down. So star has more precedence. Star has more precedence than plus. So here star is input and plus is top of the stack. So input is greater than top of the stack. So therefore we have to push the symbol. Simply push the star. So plus and this star. This remains the same. Now scan the next symbol which is M. Okay, so M is an operand. So what we have to do? Without looking at the rules, we can say we have already checked 3 operands and we have done the same thing to all the 3 operands. We have only one rule when it is an operand, what it is. We just need to output it. So the stack remains same. We just have to output the operand. Next is again an operator slash. So now what we have to do? So we have the input as slash and we have the top of the stack as star. So now the two symbols are slash and star. Input is slash and top of the stack is star. So both of this have same precedence. See, both of this have same precedence. The condition here, input is equal to TOS. And now we have to check the associativity. This for division and multiplication, associativity is left to right. We have already written here. Associativity is left to right except for exponential. For all others, associativity is left to right. So of course in this case, associativity is left to right. For left to right, what does the rule says? Pop, check again. So we are going to pop what is on the top of stack. This what is on. So this is how our stack is. Okay, this is how our stack is. We are pushing through this way and popping through this way. Instead of drawing it in this way, usually stack is represented as this way. So instead of doing it in this way, due to space constraint, I am just drawing it horizontally. Okay, so now what we have to do is, what does the rule says? So it falls under this condition. What does the rule says? Pop and check again. So I will be popping the star. So popping to where? Popping to output. So we have output as KLM. We will pop this star. So star will come here. Now we don't have star here, we have only plus. Okay, so what does it say? Pop and check again. So we have popped. Now we are going to check again the condition, that is now the input is slash and the top of the stack has changed from star to plus, because star we have already popped. So now star is not present in this stack. Stack has only plus. So slash and plus, which one has the more precedence? Slash has more precedence, right? Slash and plus. Slash has more precedence. So which case? So input is greater than TOS. So this case, input is greater than TOS. In that case, push the symbol. So what is the current symbol? Slash. So along with plus, we are pushing slash. So this area is clear, right? Now what we have to see next is n. So n is an operand. We are going to just output it. This remains the same. So next is minus, which is an operator. Minus is an operator. So what happens when an operator comes? We have to check this with the top of the stack. So minus and slash. So minus is having less precedence than over slash. Am I right? Minus is it is having the least precedence. What does that mean? Input is lesser than TOS. In that case, what we have to do? Pop and check again. So we are going to pop this slash out. So KLM star N division. We have popped it. Now the stack has only plus. Check again. Check the precedence of minus and plus, which is having same precedence. So if that is input equal to TOS. If it is having same precedence, what we have to do? We have to check for associativity. So minus and plus is having associativity L to R. So we have to use this L to R, pop, check again. So we are going to pop this plus as well. Okay, pop, we are going to check it. Now the stack is again empty. Okay, so which condition does it falls to? So it is empty. So we are going to check again. That is, we have incoming as minus, that is input as minus, and the stack is empty. So which condition? Input, we have an operator that is minus and the stack is empty. So what we have to do? Push the symbol. So how can we push the symbol? This is minus, so we will simply push this minus inside. So next input is opening bracket. So that is the next input. So we'll see what we can do with opening bracket. So if we are scanning an opening bracket, we have to simply push the symbol. So we'll simply push it along with minus. So minus and opening bracket. This remains the same. Next we have an operand O. So we'll be outputting the operand. This remains the same. Next we have plus, which is a operator. So what happens if we see an operator? We are having an operator. The stack is not empty. And what is the top of stack? Top of the stack is now opening bracket, right? So if the top of the stack is opening bracket, push the symbol. That is what we need to do. We need to push this symbol. So minus opening bracket, we will be pushing this plus inside. And our output remains the same. Okay. So next is K. K, which is an operand. So just output it. Stack remains same. Next we have closing bracket. So what to do if we encounter a closing bracket? So now that we have scanned closing bracket, so this is closing bracket. What to do? Pop until you see, this is opening bracket, okay. Pop until you see opening bracket and discard both the brackets. So you have to pop the contents of stack until you see the opening bracket. So what happens is, so this is our output. So we have to pop it, pop everything. What is there? Plus, then comes the opening bracket. So till we see an opening bracket, we have to pop. And what we should do with this opening bracket and this closing bracket? Simply discard it. Don't include it anywhere. Okay, simply discard it. So what is in the stack? So we have popped this plus, we have discarded this opening bracket, now we have only minus. So what is the next symbol? It is exponential. So we have minus exponential, which is having higher precedence. Input is having higher precedence, right? That is, exponential is having the topmost precedence. So input having the higher precedence, what you should do? So now that input is having higher precedence than top of stack, we should simply push the symbol. So we will be pushing this exponential symbol along with the existing operator. Plus. So the next symbol is P, which is a operand. So KLM star n slash plus OK plus, we have to just output P. So we'll just stacks remains the same. Next is exponential. So what we have to do? So we encountered an operator, right? And there is all the top of the stack is also exponential. So that means input is equal to TOS. The precedence of input and precedence of top of the stack is same. So what we should do? Input is equal to TOS. We have to check for the associativity, right? So what is the associativity of exponential? It is right to left. So we have to follow this rule, right to left, which is push. So we have to push this. So this is the current content of the stack. Along with that, we are going to push this exponential operator, and output remains same, plus P. So what is the last symbol, which is an operand, Q? So stack remains same, we will just output Q. We will just output this Q. Okay, so we are done. We don't have any more inputs. So what we should do? So finally we reach the end of input. So we should just pop until the stack is empty. So check if the stack is empty. No, to keep popping it until it becomes empty. So how to pop first? So this is how the stack is. So first we will be popping this exponential, then this exponential, then minus. So this is the final postfix expression. KLM star n slash plus OK plus PQ exponential operator minus. So in order to solve this question, we have used this rule chart and this precedence and associativity. So try to solve 2 or 3 questions from this area using the stack method so that these rules will be familiar to you. And if you are stuck somewhere or if you have any queries, you can email me. Thank you.